All right, so let's discuss the limit of a function. So again, this topic is an introduction to the derivatives or your differentiation topic later on. So probably if you go back in history, before the derivatives came, um, the limit of a function was first introduced and then was further developed into the derivatives or the differentiation techniques. So later on, the following sessions, you'll be able to appreciate the limits because that's where the derivatives came from, especially the three-step rule wherein we're going to be manually doing uh, the derivatives. So from the limits going towards the three-step rule, going towards the derivatives. Okay. Okay, so in this lecture, we're going to just discuss the different um, types of limit theorems. So theorems are just concepts or ideas wherein we're going to use them later on, such in the simplification processes of your functions in the limits. So yeah, we're going to discuss only the limit theorems, and I think I'm going to present you with 10. So 10 and then with each example. But first, let's define what the limit of a function is. So the definition of a limit of a function, so if you're going to read this, let f be a function okay, defined at every number in some open interval containing a, so this is a in the equation, except possibly at the number at itself. So of course, we're not going to let the function of x be equal to itself because probably if you're going to, for example, um, your equation is 3 minus x. So if it's the number at itself, so it will create a zero effect, diba? Okay, so the equation here reads as the limit of x as x approaches a is L. So that's how you read this equation. So the limit, so you first read this one, the limit then of f of x as x approaches a. So usually is the equal sign, is L. Okay, so L is more likely the answer of the limit of the function of x as x approaches a. So usually what we're going to do with the limits equation or the limits ng mga declaration is that we're going to just plug in the value of a in your equation or whatever value that the limit is giving or presenting. So it may be as x approaches -1, as x approaches to infinity. So it may be in that particular limit also. So we also have infinite limits, negative infinity, infinite limits, and so we also have finite limits, so meaning it's bounded limits. So 4, 5, etc., so on and so forth. So if the following statement is true, so if you try to read this one, so any set of numbers that is this particular term here is greater than 0. Okay, so however small, there exists a change. So this delta here is what you call as change. So I think this is the small delta na letter. So if it's capital, so probably it's this one or this one man siguro to. Then it's lowercase delta is this one. Okay, so again, any set of numbers, okay, such that if 0 is greater than the absolute value of x minus a, should also be greater than the change of the number. So, maragbali lang siya, no? So, it's lesser than, di ba? But if you're going to read it in reverse, so the change should be greater than this one. And then the absolute value of x minus a should be greater than 0. Okay. So then the function of x minus l should be lesser than the set of numbers being presented. Okay, so probably you won't be able to appreciate the definition, but it's totally fine since it's not really useful in some of the topics that we're going to discuss. So I just presented it, but at least you can you'll able to appreciate the equation itself on how to read it, on how to define some of the terms that the definition has presented. So muna siya mga E, mga change in delta. So those are the different terms that you are going to be seeing at different books or references. Okay, so let's start with the first limit theorem, which is the limit of a linear function. So if m and b are any constants, so take note that the m and the b are constants, so meaning there are numbers, 1, 2, 3, 4, 5, or it could be integers. So as long as they are constant, meaning numbers, they are not represented by letters or variables. So the limit shows here that the limit of mx plus b as x approaches a is equal to ma plus b. So how are we going to understand further this particular limit theorem? So since going back to the title, limit of a linear function. Linear means line, di ba? Okay. And we know by fact that in our high school days, in our senior high days siguro, that the equation of the line is y is equal to mx plus b, diba? So let's try to recall some of the equation here. So y is the point in the y-axis, but then m is the slope, which is defined as the rise over run, diba? X is the point in x-axis, diba? And then b is the y-intercept. Okay, so that's why we have here mx plus b in the limit. So again, if you are going to have the limit of a linear function, so if you have the limit of the function of a line, which is mx plus b, so usually we present it as y is equal to mx plus b. So we can also present it as the function of x is equal to mx plus b. So you can present y as f of x. So those are the same thing. So maragmura na siya mo sa, but totally the same equation. So just represented in another manner. Okay, so again, going back to this one. So the limit of mx plus b as x approaches a is equal to ma plus b. So what we did here was we just do a direct substitution. Ba? So ma plus b. So that's how the first limit theorem works. So for example, find the limit of f of x equals 9x minus 2 at x equals 6. So what will happen here is that we're just going to plug in the value of 6 in the equation. So meaning we're going to have f of x equals 9x minus 2. Then as the limit approaches 6. So meaning we're just going to have, or we're just going to plug in, bali din akong pag. I wrote it in a wrong manner. So the limit of x as x approaches 6. Okay, so again, direct substitution. So meaning this will give us, so this will give us 9 times 6 minus 2. So this will give us 54 minus 2. So the answer would be 52. The limit of f of x as x approaches 6 is 52. Okay, so pretty simple, di ba? So let's try number 2 instead. So next is the limit of, so again, we try to rewrite this one in terms of the presented equation above. So the limit of f of x as x approaches 4. So the equation given is square root of x. So this one is square root, but in word format, parag puto lang ang square root function. But this one is square root of x. So again, direct substitution. So square root of 4, and this will give you 2. So ano na siya, marag simple na kaya. Okay, so I think probably you won't be having any questions for this particular theorem since it's super simple, since you're just going to directly substitute the value of the limits in the equation. Okay, so next is the limit of a constant. So if c is a constant, then for any number a, the limit of c as x approaches a is equal to c itself. So again, the limit of c, which is the constant, as x approaches a is equal to c. So what we mean by this is that if you try to look at the example, so again, if you try to rewrite this one, the limit of 5 as x approaches 2. So again, the same as the previous theorem, we're going to plug in 2 to any x value, diba? So that's the purpose of this kani siya mga inani dire. as x approaches 2. So we need to um, substitute it with the variable x. But since in this particular example, we don't have any variables of x, so the answer is just 5, diba? Because we won't be able to replace any value of x in the equation. So that's why if you're just given a constant in the equation and the equation is trying to look for a limit, so probably the limit is just the constant itself, since again, you cannot um, replace any value for x because there's no x variable present in the equation. So mura na siya. Super simple. All right, so I think that's for number. So the next limit is the limit of the identity function. Okay, so if c is constant, and then for any number a, so as the limit of x as x approaches a is still a. So again, we just have to plug in the value of the limit. So in this case, the limit of x as x approaches 2. So you just have to plug in the value of 2 to x. So murag super simple kay siya, diba? So those are the basics man siguro. So next would be the limit of the sum and difference of two functions. So this might get complicated, but it's pretty simple to understand since atong button is you're just going to create two different types of limits. Okay, so sum and difference. So sum and difference have the same process, but one lang siya, diba? One is adding, one is subtracting. But sila ang pairs sa operations, diba? The same, marag sila ang pair. For product and quotient, they could be the pair, but in quotient, there's just a special case for quotient. Okay, the denominator should not be equal to 0. Okay, if you divide by 0, the answer would be undefined, diba? So probably that's the special case for quotient. So for sum and differences, for the sum and difference of two functions, so there's probably no special case or special rule for these operations. So if you try to read the definition, so if the function of x as x approaches a is equal to L, so let's say the function of x could be any function or any equation, then the particular answer is L. Diba? The limit of g of x, so again, g of x is another function, as x approaches a is equal to m. So the limit of the given function of g of x is equal to m. So if you have two equations or two, let's say, addends or subtrahend, usay na mga terms sa kan. So I forgot. Sama na siya. So if you have two terms in the operation, whether it's sum or difference, so for example, the limit of f of x plus g of x as x approaches a is equal to L plus or minus m. So in simpler terms, for you to be able to understand this limit theorem number 4, so all you have to do is just to expand the equation. So try to distribute this one to the first one and then distribute the limit to the second term. So if we're going to distribute that, you're going to have the limit of 4x as x approaches -3, and then plus the limit of 2 as x approaches -3. So, mura siyang yung may ang ma-happen sa kanina theorem. You're just going to expand this one. We're going to set limits for each term in the equation. Okay, so this one is just a simple um, equation, but again, if you are presented with a complicated equation, so that's the time that you're going to have to expand the limit. So probably if you're trying to look at the function, it's similar to the first theorem, which is the linear function theorem. Okay, this one is mx plus b, magyapon na siya nga format, diba? So again, this is just for the sake of discussing it in a simple manner. So going beyond the koan, so if you try to imagine, so let's say you have 4x squared. So let's say you have 4x squared plus 2x. So this one is not linear anymore, diba? So again, what you need to do is to split this one into two different limits for you to be able to understand the limits. So again, if we try to solve this one, so the first limit is the identity limit, since we're just going to plug in the value of x in the equation. This one is the constant theorem, which is the limit of c as x approaches a is just equal to the number itself, which is c. Okay, so this would give us 4 times -3. Then again, the second one is the constant limit. The constant limit theorem. So this would give us still 2. So you're going to have -12 plus 2 is equal to -10. So that would be the answer. So murag ana ra siya ka simple ang kaning theorem. Okay, so going on with the next one is we have the sum and difference of n functions. So meaning if you have plenty of functions, this will be the same as the previous theorem, but you're just going to have multiple number of limits equation. So for example, you're going to have 5. So of course, you're going to have 5 of these limits. And so 5 different limits. That's why you have L1, L sub 2, up until the last limit equation ngayon yung solve. Okay. So next limit would be the limit of the product of two functions. So the limit of, again, the same definition as the limit of the sum and difference. So the first limit would be L. Another function would be, the answer is M. Okay. So the same as the product in the sum and difference limit. So for example, again, let's try to read first the equation. The limit of f of x times g of x as x approaches a is equal to L times M. So meaning this one is the answer for f of x. This one is the answer for g of x. So how can we understand this further? So still the same as the sum and difference theorem. So we have to separate it into two types of limits. But this time, we are multiplying the equations instead of adding or subtracting them. So again, one limit for the first term or for the first factor. So I think that's what you call the specific items in the product or the multiplication process, diba? Multiplying factors. So the other one is the second factor. So if we try to rewrite the equation, so the limit of x approaches 2 for the first factor would be x minus 1, and then multiplied by the limit of 2x as x approaches 2. Okay, so if you're going to ask me why are we going to separate them when we can just in fact just directly substitute 2 into the equation, same as the previous theorems, diba? So why do you still need to split them into different parts? So most likely later on when we reach the three-step rule, so the simplification process, or let's say the splitting of the different items or the factors in the equation would help us simplify further the equation. So, so instead of directly substituting the value of x, so we try to dissect each element first so that we can see whether we can simplify the equation first before applying the limit of a. Ba? So murag mo na siyang technique. So instead of adding, ba? So mura na siya kanang sa inyohang kuan good sa how can you relate this one? So I think it's the same as the kanang mga kanang inyong utang-utang, di ba? So for example, you have debt. So murag mas dali man nga murag pag-eliminate daan sa other factors, di ba? So, probably dili siguro sa utang, but mas magna na siya nga style like you're going to simplify everything before applying the limit of a. So I think probably this will be the use of the limit theorems that I am discussing. So it's for the purpose of getting a simpler equation later on in the next topic. I think next topic. Okay, so if we're going to try to dissect even further, so if we're going to look at the first factor, this is the sum and difference theorem. So we can further dissect this one. So again, if you are confused on how the bracketing system works, so first is parentheses and then braces and then brackets. So that's how the enclosement is ordered. First is parentheses, next is braces, next is brackets. Probably this one is braces, bracket man siguro. So it might be interchange on terms, but wala siya ang order. Okay, so since the first one is, we can further simplify this one into the sum and difference. So again, what we're going to do is to, to distribute the limit. So this becomes the limit of x as x approaches 2 minus the limit of 1 as x approaches 2. And then multiplied by the limit of 2x as x approaches 2. So di ba, murag super simplified siya. So probably the ang kaning second theorem can further be simplified since it's still a product of two functions. So if we're going to again dissect this one, so we have the limit of 2 first and the limit of x. So multiply it again. This becomes the limit of 2 as x approaches 2, and then multiplied by the limit of x as x approaches 2. So mura copy kay siya paminaw no kay sige ta og dissect of equations. But again, the purpose of these theorems would be for the simplification process of the equations. So sige lang, ini kaabot dito sa next topic is dito mo libog-libogon. I will be going straight to the point with the process of the solutions. So dito mo balik sa kanang mga basic stuff like these limit theorems, but probably we'll just touch those theorems by just recalling it lang siguro. Dili purely applying it. It will be applying the theorems but totally not in a geeky way. Kanang kuan siya. Right, to remind us that this part was coming from this theorem. Ayan as yung pagkadating. Okay. So if we have the sum and difference of n functions, it's the same as the product operation. So you can have infinite limits of products, or let's say factors rather. So if you have plenty of factors, so meaning you're going to have plenty of limits. So let's say you're going to have 36 factors, so you're going to have up until the limit up until 36 na term, diba? So probably kanang di ta maabot ana, but of course probably at max you're going to deal with 3 or 2 na. Let's say x cubed, diba? X times x times x. So it could be in that manner. Or you're going to multiply 3. So for example, x minus 3, x plus 2, then x minus 1, diba? So you're going to have 3 factors. So same rule. So you're going to first create 3 limits. And then after creating 3 limits, you're going to create 2 limits for the first term, since it's the difference limit. Second one, 2 limits again. Third one, 2 limits again. So in total, you're going to have 3 product limits, but internally you have 2 more additional limits of sum and difference, which gives you a total of 6 limits equations. So 6 kay nani. So if you can imagine that one, if you're going to expand that equation. Okay. Okay, so next is the limit of the nth power of a function. So if the limit of the function of x as x approaches a is L and n is any positive integer, then the limit of the function of x raised to the power of n, so I am reading this now, the limit of the function of x as the function of x raised to the power of n as x approaches a is equal to L to the power of n. So how are we going to do this one? So it's still the same. Just have to put the limits of integration inside the equation. So for example, in this one, so again, if you notice, L is this one by the function of x raised to the power of 4. So this would become the limit. So you just have to distribute this one here. So it's not really the perfect term to use distribute, because you cannot distribute unless you expand first to the power of 4. But for the sake of simplicity, so just apply the limit in the x variable inside the kaning power function. So this would become the limit of x as x approaches -2 and then -1. So -1 is a different term. It won't be affected by the limit. Then raised to the power of 4. So muna siya, and then you're going to apply the limit. So you're going to have -2 -1, but direct substitution, the identity limit. So if you're given just a variable, just plug in the value of the limit. So -2 -1 raised to the power of 4. So -3 raised to the power of 4. So -3 raised to the power of 4 would be 81. So this would be the answer. So on 81 man, so again, if any negative number is raised to an even number, it would give us a positive answer. So 3 times 3 is 9, and another 3 times 3 is 9 again, so 81. So 3 times 3 times 3 times 3, then this would give us 9, 9, and then lastly is 81. So that would be the answer, 81. So ana na siya. If you're given a power, so there's no need for us to apply limit to 1. Okay, so next is we have the quotient of two functions. So if the limit of f of x as x approaches a is L, and then we're going to have the limit of g of x as x approaches a is equal to m, then the limit of f of x over g of x as x approaches a is equal to L all over m, or L divided by m. So meaning this would become the limit of the function of x, L, the limit of the function of g of x is m. So such that the denominator m is not equal to 0. So there's a condition for quotient function, di ba? As long as the denominator is not equal to 0, so you can apply the theorem. So probably in most cases, we try to avoid the denominator being equal to 0 for us to avoid an invalid answer. So usually what happens in the calculator, I think it's math error, or if you're going to divide any number with 0, it could be, I think the answer is math error or probably invalid answer. So let's try it. So it gives math error there. Math error ang magawa sa calculator. But in mathematical terms, if you divide any number by 0, it is undefined. So it's better to have the 0 in the numerator, because 0 divided by any number is still 0. So special case lang is you don't divide by 0. Diba? So mara nag-pizza, di ba? So if you're going to divide the pizza by 0, so ano man yung answer, di ba? So wala mo i-divide yun actually. Okay, so if you're going towards the example, so again, the same as the product rule. So you just have to distribute this one. So you're going to have the limit of x approaches to, and then x minus 1 all over the limit as x approaches to, then 2x. Now, then if you want to further dissect this one or further integrate it into different parts, so the numerator is again the difference of two functions. The denominator is the product of two functions. So further expansion of this one would give us the limit of x as x approaches to 2, then minus the limit of 1 as x approaches to 2. And then the limit of x approaches to 2, then 2, then multiplied by the limit of x as x approaches to 2. So ana siya. So as you can see, it's similar, di ba? But since we cannot cancel them out, since the operation in the numerator is minus, so if it's plus, I mean if it's multiplication, so we can cancel this one out, di ba? So again, that's the purpose of having these theorems. We can cancel the terms out later on if they have a common term of limits. So that's how you deal with this one. Okay, so you have 2 minus 1 all over 2 minus 2. 2 times 2 there. So the answer would be 1/4. Okay. So last but not the least is we have the nth root of a function limit. So if the limit of the function of x as x approaches a is equal to L, and n is any positive integer. So usually in root functions or radical expressions, so basta mga square root ka ng mga balay-balay, the correct term for that one in mathematical terms is radical expressions. Now, if you have to deal with square roots, cube roots, those are radical expressions. So of course, our index would be positive because we don't see negative index sa inyong radical expressions. So wala may the negative square root, diba? Or the negative cube root of this particular number. So we always have a positive index in your radical expression. So this one is the index. So of course, if wala siya number, so that would be the square root, diba? But again, it could be a higher degree of root function. So it could be cube root. So usually, pwede siya 3, pwede siya 4th root, pwede siya 5th root, depending on the problem. So the problem states that if you have this particular function, so you're going to replicate it in this manner. So again, we have this one as L. So meaning, if you try to understand this one in a simpler fashion, so just try to distribute the limit towards the x variable, which is the function of x. So this would give us the 4th root of the limit of 2x plus 1 as x approaches 3. So I think that would be on how you're going to understand it. So just try to put the limit inside the radical symbol, diba? Siya. So again, notice that L is the limit of f of x as x approaches a. So it's just expressed in another manner, di ba? So ang limit, you just have to place inside the radical expression. So isuot sa balay, di ba? Maraman balay-balay ang radical expression. So of course, if you try to answer this one, so you're going to have to expand this one further. So by product rule, so 2 times x plus 1, and then expand it even further using the additional, the sum function limit. And then identity limit, constant limit, then you're going to have the answer. All right. So I think that would be the end of the lecture for today. So probably we're just going to have 1 hour for each session para dili kayo makalitan. And also that's why we're going to have 1 hour because wala mag-ni-overlap ang inyong time sa ako ang next class. And then my next class is a major class sa CE. And it starts at 8:30. So at least it will give me time to prepare sad, and it would give me some water break sa kaninga class towards the next class. And then after sa akong class po na napoy 10:30, so 3 straight classes. So 1 hour lang tayo every meeting, okay? And then that's it. So see you all on Thursday, and I'm going to post this recording later. After, I think probably in the afternoon after my morning class has ended.